Cool. So we have another bit of a, I guess, follow-up on last video, refactoring day. So I think I'm gonna just get rid of these thing here. Gonna make the whole thing a bit more readable. Real and imaginary. Yeah, I think I'm gonna leave it like that. Just gonna make that more complicated otherwise. And I remove the qubit from here because I wanna basically use I'm just gonna use the edges. I'm not gonna use the system edge. I'm gonna use, like I did here, qubit edges. Okay, and they're gonna be like, with Q and yeah, we'll actually take that over later when I'm able to code these a bit more to actually to systematically build that, programmatically build that. So I need to refactor these. So we have a system here. New system is just empty. I really don't like. I don't care how many qubits we have, right? So let me just do these. So actually from state, because I'm using these to start the whole thing. So there's going to be Q0, and then we have one vector that's going to be more readable, one state, and then I want to have the state and I don't care about these. So that is one state, and now we want to have. So maybe I should just do it like these. And now what we want to have is we want to have sort of Q1, right? And have the state. Okay. And here, to be honest, we shouldn't care what we are giving in here right now. So Q0, Q1 from state vector. Cool. One is going to be, they should be the same because they are in different edges. That was the problem, that I actually have to encode these anyway, because otherwise it thinks it's the same. It thinks it's the same node. That's the problem. That I still gotta do these. Yeah, that's messy because I probably just want to give like. Can I just give it a random ID? I really don't care at that time. So right now, like Python random unique identifier, or I could just like use some kind of global. Like I want something small. I really don't have to. I think I'm gonna go with a dummy global variable that's called just like node number, which starts at 0, which starts at like n0. Yeah. Oh, what am I doing? And then so this is just just a workaround to make sure hypergraph nodes are unique, and so it's going to be basically Q0 plus, does this work? I'm not sure this works like that in Python, but yeah, initial state. And so, and then what I'm doing is actually I do need this thing here. So qubit plus, and goes like that, right? That's what I'm using there. Okay. Okay, we're back here. So let's rewrite these apply gate stuff, right? So what this does as a new system, we've got edges and we get the components. So we print the components. We've got none. Then we go for all edges. So let me just not, for all edges, get the nodes in the edges. Node state. Okay, so first of all, I shouldn't do these like that. Okay, so what I should do is not for all edges. I don't care about these. What I care is about. But this was not working, right? Like last time I tried, this was not working when I was doing get. What's the documentation? Because I don't have to do this for all edges, because I'm just applying a gate and I know the edge that I want because I have the qubit. So, and I know that the edges are named just like that, and so hypergraphs, classes package, submodules, blah blah blah, the hypergraph module. So get edge, edge, edges, edges, edges. Get edge, edge, add edge, remove edge. Add node to edge. Must belong to self dot edges. Okay, so if I bipartite, collapse edges, collapse nodes, components, degree, property edges, dictionary of entity set of hyperedges. So if I say edges, right, if I say in system edges and I use qubit, like that should give me the nodes in the edge, and so I can go and say print node, and I can go and I think that works. And so what I just do is okay, so this should basically I don't care about the edges. I declare the new system. Also, I don't want to declare the new system. I think I'm just going to modify the system. I think that's going to be the smartest thing to do here. So for all the nodes in here, just print the node, and then print whatever, and then return just system. Okay. So we're just doing like, okay, so we're from state vector and then applying the Q0 the gate X. Let's see what we get. Invalid syntax. Oh, so I cannot do it like... Oh, I'm missing something, I think. Oh, I think I need to cast it to int. To string. Can I cast like that? No. Oh god. Just str. Okay, cool. Exactly like that. Str like that. Invalid syntax. Okay, so I guess I just have to say qubit 0 equals you know, so just like these. Come on. Just like that, but like without these, and then we increment this. You know what? Actually, that's stupid. I just should do something really easy. Def get UID, and that just you know, like that actually. So we have these in here. That's 0, and then we just do node nb equals node nb plus 1, return node nb minus 1. That's what we do. So, and then it's as simple as this, so I don't have to deal with that every time. And then I just do and then I just do what I've always wanted to do, which is q0 underscore plus, and now I just do get UID. That's how we are gonna do it. And we're gonna call this like that. Let's see if that works. Seems to work. Why is that so long? Encode state is not defined. Where am I using it? Encode state. Why is it not defined? I haven't run this? Looks like I haven't run this. Can only contain strings, not inst strings. Yeah, well, because I'm kind of stupid, basically. Oh, there you go. Okay, cool. So we have it. So Q0. Okay, so we print the nodes. So actually have access to the nodes. That's awesome. Now we take this away and say we decode the node. We get the node state. We don't care about these because we know that we're on the right nodes. So we print the node before we get the new state, and then what we do now is we say, so we should flag, that's the problem, that we should flag these nodes as, we should just replace the node, okay? So how was these? Remove. From edge, I think. Remove element. Removes item from entity and reference to entity from item memberships. Remove element. So maybe I can just say, can I just say, yo, system, remove element, the node basically, and system, not system, but like these, right? And so, add element entities and assign entities to item membership. So add element, so I can just say, then just take this whole thing and just say add element. Add element encode state. Encode state of basically essentially this whole thing, but I just gotta call these the qubit. I don't need to call this qubit, can I just want to give it the QID? I don't really get why I'm so stupid and stubborn in adding this part. I'm just getting a unique identifier and that's all I want. Just getting a unique identifier and that's all I want. Yeah, maybe I should just return like these, okay? So it returns like just something that looks like that's an ID, okay? So so just get that. That's it. Get these. They're always different. And what am I doing? Apply gate. And I'm adding the element and then return the system. Will that work? We don't know. It's not initial state, but new state. Key error. So this seems like it happened. At least one node. Okay, so add element. Remove element node. And I'm adding the element to the system, right? So we have these in here. So we don't need to print this, so this works well. Then I remove the element and add the new element. Hmm. So how do I returns the new entity? Actually, I think that is the problem. Okay, and there that actually returns the element and the remove element. What does it? It also returns. Removes it item from entity and reference to entity from item ship. Okay, so I get it. So I think what is it possible that we should just do it like this? That this actually just returns the. Not so sure, but it could be item assignment. No. So, but that breaks, right? So it tells me there's no at least one node. Oh, but it says key error. So it does something weird with these being the key. Why there's a 0 in here when I'm... Well, I should probably run these first and then run these. Maybe the problem is... Okay, ID 0. Hmm. So if I don't remove the element, then what happens? Ooh, something's really wrong here. Key error. Why is this key error? If length of edge, then something with the T's being the key. It seems like it doesn't like it. Like if I don't do anything with it, then it's ID 0, it does this. Oh, I mean, that is definitely a problem. Node NB. It's not local. Do I have to just call this global or something? I've seen this being done somewhere, but I don't know what the effect really is. Invalid syntax. Before assignment. Python global variables for UIDs. I don't really at this point care of making something that's, you know, good, but global. Global variables. How do I need to call them inside a function? X awesome. Yeah. The global keyword. When you create a variable inside a function, the variable is local. You can only use inside the function. To get a global inside a function, you can use the global keyword. Okay, so that's not what I want. But that means what I had before was just kind of okay, right? So I have these, you know, global variables, aux functions, and so I just say this is what it is, and so basically read these, and yeah. What is the problem with that? Python modify global variable inside function. Maybe it's just maybe I have to tell it that it's global, so that I'm using the global one. Oh, okay. Global total. Okay, so that was my suspicion. So I need to call these. I need to declare. I need to just use the global keyword in here, and then that should do the job. Yeah, okay, now I got the two things. Cool. And now let's try to do this, right? So hopefully it won't break. Why does it break? Okay, but now ID4 makes sense. Maybe it breaks because... What? Oh, there's definitely something dangerous in here, right? Because it's I'm adding elements to something I'm already iterating on, so that is definitely not a good idea, I think. Remove elements from. Iterable of hashables or entities. Hashabal entity. the iterable. So I can I just say, you know, garbage new nodes, and then just basically say garbage append node and new nodes append the, you know, I'm so lazy that I'm just gonna garbage append node, and this is basically just new nodes append this whole thing, and then out of the loop just go and say system I'm gonna use removes are some entities elements if they belong to this. I think. What is the different? Oh, that returns self. That as well. What is the difference though? Remove args. Remove elements from an arg set. Iterable of hashable of entities, and this is one or more hashable or entities. Okay, just remove. So I just remove garbage, add new nodes. Does this work? Not at least. How do I build like an iterable? Like what's the point? Like it's not hashable. Why is it not hashable? I'm so bad at these. Remove one or more hashables or entities. That's maybe where they remove from. Remove elements from an iterable. So maybe that's the point of these, that I can just pass it over. Then add elements from an iterable. Like exactly. The name is weird though. Oh, come on. Same key error. Crap. Why? So after doing these, what if I just do these and we don't draw the thing? So it just has one thing, ID 13. Okay, but that's not good. Well, no, that's fine. I guess that's just fine. What's the point? What's the wrong? System edges. Why is the printing not working? That's what I don't get. Edge UID. Key error. That is what creates the error. I think that is the problem. ID 23, 23, 24. I'm just not using the right, like, this is an edge basically, right? So if I just print these, it prints Q0, that's the edge. Like, if I remove the garbage, so what is the size? Size 1. It's got one node. If I remove the element, then it's got 0 nodes. Well, look, you can actually do that and it prints stuff correctly. If I add the new nodes, that's when bad things happen. It has 1. Oh, okay, because this element is now sort of orphaned. Probably that's why this is happening. Is it? I should just hypergraph module, the object parameters, add edges from add node to edge. Oh, that's what I should. Okay. Oh, is there like remove? Remove node. Ah, that's probably the reason. Remove node. Okay, yeah. So I should just say system remove node. System remove node. So I remove the node from the system. Then first of all I get the nodes 1 and ones. Exactly. and then I can still now basically say also remove node, and then I also can say system add node to edge, and give it the node and the edge. Yay! The node and the edge, which is basically this. Okay, that is cool. That should work. Nodes, nodes, nodes. Oh, yes, God, finally. Okay, perfect. It's a 1 now. That works. So I think I'm done with apply gate. Now it's nice, clean, perfect. Now, how does the control look like? And really similar idea, right? Remember these. So, and I wanted to see if I could today basically try to also implement the other edge cases, but I think I'll just keep refactoring. I think I just have to get it to work in a way that I'm happy with it. So that does the job. And now when it applies, we're going to apply a control node. So basically, we want to see here the split happening, right? So we what we want to do is we want to apply a Hadamard gate, right? So we're actually getting this beast in here. Should probably cap those numbers with precision and stuff. How was this on Python? Python show only 3 decimals. Okay, just round. So with the encoding, and with this I can do in the encoding functions. I can just say round these by 2, by 3 actually, I should say. So huh? Oh, there you go. Okay, cool. So there, cool. And now we do so here. So what we're doing here, so we get the nodes, right, of the control. Control nodes. Oh, gosh. Control nodes. I think I need to change the batteries of the keyboard soon. So probably we don't need these. So we need the control nodes. Then for each node, we don't need this edge thingy here. So for each node, maybe that would be the easiest to do anyway, because we need to duplicate it. I think it will be the easiest to just refactor it, like I'm replacing the thing again. I think that's going to be there, because I can, there's is there like add nodes from add edges from, add node to edge. Add node to edge. That's just the only thing that you can. Yeah, I think that's the. So it looks like I only have node to edge kind of thing. Add edges to hypergraph. Remove edge. I think I'll have to go with these new nodes, new edge, and I just get the control nodes, and so I'm creating these, and this is all, you know, all good, all good, all good. I get the node 0, node 1, event superposition. We're splitting these, and so we have the target system, blah, blah, blah. We just get everything, and I think that the only way to refactor that is just saying, so you have the new nodes that go to the control. So what I'm just saying is system. So I'm saying something different, which I'm saying just system do I have to do this? Actually, I might not have to do that, right? Because nodes target. Yeah, I want to add them to the qubit edge. So I want to say system new nodes. So totally. So actually, yeah. So I just basically should say. God. How do I do this? Edge order. Number of edges. Neighbors. Edges from. I think I should just use this one. Because this basically you give it like you're literally add edges to hypergraph. Add edge, single edge to the hypergraph. Hashable or entity. And this children must be removed so that nodes do not have elements. Each node element of edge must be instantiated as a node, making sure that this isn't already present in the self. Edge set. So add edge. Add edge. Children must be removed, blah 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 blah. It's a hashable or an entity. So it just can be the edge returned will be empty. Don't get it. So can it just be system remove edge. Control system add edge, and then I just kind of go like that, like but that's bad because that's the problem here is that if I have, I think that if I have I'm so stupid because I should just have stayed to what I had and just have a dim function that converts my notion of hypergraph to this library, maybe to just print it nicely. But I don't know, because if I have, so if I have, or if I'm destroying the qubit edge and these nodes were sort of connected to other stuff, like it's almost like what I'm doing is I'm taking these controls, blah blah blah, and then target 0, new nodes. I calculate the new node, and I'm adding these nodes to the edges that they need to be added. Now let's try. Okay, so remove edge control, and then add edge, and then this was like control, not control, but like control, and then it was just basically new nodes. But this now I need to do the encoding. Okay, so it was something like that, and then I need to do this for the target as well. Bah. So I need to say, you know, like in these we don't, I think these we just don't care. Target, then target 1. So what are we doing here, right? So we're target 1, target 0, edge 1, edge 0. Oh yeah, well, I need to add the new edges because these are the entanglement edges, okay? But then let's see. Okay, I get it. So I just have to use encode state, get UID. That's the state, right? So basically, target 1, append, and then that is what we're doing. And here we're doing the same. I don't know if this refactoring is gonna work. Should route this that well. So I'm encoding the states. Control nodes, encoded node, and then I just say node equals decode. Is it called decode state? Decode state. Encoded node. That's an important thing to add as well. So we're decoding it, and then we have the actual node. The actual node is given in the one component, so I should actually do this. And then we're doing like all this kind of stuff, right? I don't know. So what if I do apply control gate and I apply system Q0 Q1 and next system Q0 Q1 and the next. It's gonna blow up. Memberships, edges, control nodes. Yeah, I'm stupid. It's not like this. It's not like that, and it's not like that. It's system edges, exactly. So I'm using system edges control. Here I'm using system edges target. And here I'm using system edges target. Can I cast array data from D-type complex, D-type unique rules safe? You're not. Gate for n in. What do I just say? N for now. Okay, so let's just ignore these for a second. Just want to make sure that it works. Real. Okay, so here there's the encode. Those are not. Those are not NP arrays. NumPy arrays. When I decode, it's an NP array, yeah. It's an NP array. So when I give it like the N, oh, sorry. Actually, I should decode state. I should do like these. That for sure. So what if I do this? NP array. Does this work? Just wanna print these. So actually prints. So actually print something like so. If I do this and I print that, now what's the problem? So that's worked, and now what's the problem? It's telling me that it happens in edgepen target 0. Oh, that happens here. Not there. I guess this happens in here. So this node 0 and node 1 are the decoded state. Okay, so I should actually yeah, but that's correct. I'm encoding it. Who's target 0? Sorry, target 0. I'm stupid. Where's target 0? System edge. Target. Huh? So what is these? Target 0. Oh, so all those are all the nodes. I get it. Those are all the nodes. Yeah. I think I don't. Yeah, those things are not to be encoded. Let's just forget about these for a second. Let's just forget about these for a second, okay? Because this is the edge stuff. This is sort of the new edge that we're creating. I just wanted to make sure that the rest works well, and we'll just call it a day, I think. And hash all type dictionary. High edge. Okay, that's not how this works. Just tuples like that, okay? Add edges from edge set. And iterable. Add edge. Hash all or an entity. How do I add an edge? Add edge, just these, right? I just add edge. So I should create an entity maybe and add these. I guess that's what this is telling me. New entity. Entity X. So that's the edge, and then add element. Add elements from, I guess that's what we want. So something like I should do control edge equals entity with the name of the control, right? And then just control edge add elements from, and then new nodes, and then add edge, and then we add the edge. I think that should be the way this works. We remove the edge and then we create a new edge. Oh yeah, there you go. Cool, that worked. Ah, nice. Okay, perfect. So now we do the same for qubit, for the target qubit. So that's target. Man, that's complicated to write. That's target. And add elements from, and then we do these, right? And then, okay, so that's going to be the target edge. And we add this edge. So I guess what we can do is just do it like this and call this twice with the other element, target 1. And there you go. Okay, cool. So we have, and now we've got these superposition that's been split. Okay. Now, and the target is in the one state because we was just okay, we're not done. Target 0 and target 1. And that's kind of the stuff that I've been basically skipping in here. So, because target 0 are the elements that already exist. So that's an edge, and if we call just the elements, these are the actual elements. So this is where I need to go, probably to do dot elements or something. Okay. Yeah, I think so. Cool. One more session. Behind, but I'm still not happy with these. But okay, I managed to. I'm not so sure if this is gonna work the way I like it to work in terms of I would like the I would like the edges to so I would like I'm not so sure with this removing and removing and the fact that I'm creating new nodes completely. Well, this will work out at the end with keeping this stuff. If I have a node that is connected somewhere and I'm applying a next gate effectively, what I'm doing here is I'm literally creating a new element, right? So I should really, what I should do maybe, there should be a way to clone the element or something. The entity, right? Clone. Clone with a, okay, so that's what we should do. We should use clone. We should definitely use clone. So I should not remove the node. I should just say the new state is that. And now I should say first the clone node is node.clone with these UID. I should remove it and then I should just add this node. I think that's what I should do. I'm just gonna run this again to start from scratch with the IDs. Let's clone. The clone's not working well. Node.clone. Decode the node state. Yeah, decode. No. Clone. That's an entity, right? Turns an entity. What is the error now in here? String objects no attribute clone. That is not supposed to be a string, though. It should be elements, maybe. I think that's not callable. Ooh. Is that really a string? That's the problem. Come on. I really just want to get the elements. Or is it children? children. Oh, there you go. So it should, if I start again like this, ID 0, ID 1. Okay, but the X is, the not gate hasn't happened. Clone node, remove node. The Harmon gate hasn't happened. It's not even printing the node. Decode state. I guess I need the ID. The UID. That's what I need probably. Oh, so it's just not running. Probably nodes is empty. Edges, nodes. Children. And it just has properties. Because this is cool. Because we have, you could use properties, UID elements. Binary contain itself elements. Show the elements of its elements. I want elements. UID. Okay, so probably now. That's already. Okay, but that's a damn string. Oh god. Okay, whatever. I just had to do a use clone. Gotta go. It's definitely the right thing to do. It's taking me a lot more than I expected, but I think that's gonna be at the end. It's gonna be worth it. Cool. What am I doing? Key to add. Come on. I don't know what I'm doing. Whatever. I'll push this in a second. Bye.